Hey, welcome to another screencast. My name is Joseph Abba. In this screencast, I would be talking about generics in Go. I started playing with generics about 3 days ago, and I'm loving it. So I want to show you some of the things I've been able to do. So in this screencast, I'm going to implement a queue data structure and a linked list. So let's get started. The first thing I'm going to do is to create a new directory called list. And I also create another one called queue, Go mod init generics examples. Let's create a file in list.go, and open that file. So let's create a package list. First thing, we are going to create the node type, introduce generic here. This is struct. We're going to have the value, which will be a generic type. And we're going to have the next, which will be a pointer to node. Then we introduce a generic. Since we are encapsulating everything in this package, I won't be exposing any of this data structure. Then we create another type, which is a real linked list itself. I'm going to name it linked list. And then we need to introduce the generic as well, because we need to pass it down when we are adding head. So this is a head, and it's going to be a pointer to node. And this is why, because we need to pass the parameter down, that is why we need to introduce it here as well. If you've done any form of generic programming in Java, in C#, it's very similar to that approach. But in short, I find this more simpler than what is in Java actually. Next, I would like to add some helper method to this structure itself. So to do that, let's put all the methods very close to it. To do that, I want to be able to access the value and next. So to do that, we basically say func. So our n for node, and then let's call it value. Value returns what? Values return t, because we have it here, and we can just return n.value. So our node now has a value method. I'm going to do another one for next. So I'll just copy the signature down, rename this to next, and we have to make this pointer to node and pass down the generic, because this needs to change to next as well. Alright, so we have these two helper methods for us to, this is going to become handy when we want to start testing our linked list. The first method I'm going to add to our linked list is the ability to push something from the front. Let's define our method called push front, which will be of type. So we're adding the method to the linked list directly. Then push front, that means the value that they are going to push in, this value is what we are going to set here. So it will be of type T, because we have the T here, so we are passing it down. We're not returning anything at this point. When the list is empty, when we don't have any node on the list, that means the head will be new. So if head is new, at this point, we're just going to set head to, let's call it new node. And where is new node? We need to create new node, which will be pointer to this, pass the T, and value will be value. So that's our new node. Else, when the list is not empty, we need to do more. We need to save the old head value to, so let's call this old node, to a new variable here. The new node we're about to add dot next will be equal to the old node, and then the list.head will be equal to new node. Alright, that solves it. Then I want to add another method, so I'll take the same signature and call it head, that returns what is the value of our head is node. So we're just going to return node and pass the T down and return l.head. The reason why I'm adding this is we're going to need this in order to access the head, that is, which is the entry point to our list. So let me create a main.go now, function main. How do we create an instance then? We don't have a way to create an instance, so let's go back and add in another method called new that we can use to create the instance of the linked list. So I'm going to add it right here. It's actually not a method on the linked list, it's a general function, but we're going to name it new. and new returns this. So I'm going to take out this. But how do we then introduce generic? Very easy. You come like this, type T, type any, and then we need this to be a pointer, and that is it. You don't have it. All right, so let's go back to main and create a list dot new. So we're going to create a linked list of what? Maybe let's start with int. At this point, we can do l.pushFront 10, l.pushFront. If I type, let's say, AJ in here, you see that error is showing error. So you cannot use type AJ, which is a string, as int. This is why generics is better than just putting the generic interface there. 10, 11, let's say 12. 12 is at the front, followed by 11, followed by 10. So you are going to print them in that order. Let's do node is list.head. This is the entry point of our list. If when node is not equal to nil, we want to do something here, but we also want to change the call, node equal to node.next. So what do we want to do here? For now, we're just going to print. And remember the helper method we added to the node value. This is where we need it. Now go run main.go and we should see our 12, 11, 10, right? 12 is at the front, followed by 11, followed by 10. Fantastic. The next thing I'd like to do is to introduce the concept of adding from the back. That means we need to add more properties here. We need to have previous. We should also have a prev method now. And return prev here. That's done for helper methods. What else? So now that we have a head, let's have a tail as well. And I think that's about it. But also, when the list is new, irrespective of if you're adding from the front or back, when the list is new, both the head and the tail should be pointing to the same node. When there is nothing in the list, both the head and the tail will be pointing to the same node. But if there is something, then we want to old node for old node dot previous should be pointing to now new node. That's all the code modification that is needed here. I'm going to take the chunk of this code, paste it, and change the signature to push back. And basically, we're doing the same thing here, but just for, I can just change this to tail now, that if tail is new, that probably don't have anything in the list, we are setting this here as well. Else, old node now be the tail. This time will be the tail. New node, the new node previous will be the old node. Remember, the old node was there, so you can just, from English standpoint, as it was previously there. So, yeah. At this point, the old node.next will be equal to the new node, right? And then the list.tail is now equal to new node. So that is for push back. So we need another method for tail so that we can access the list from the back, return tail. That's it. So let's go back. If we add something from the back, so what is at the back right now? 10 is at the back. So let's add something, push back 100. So you see that 100 is now at the back. 10 was at the back. Now 100 is now at the back. How about accessing the list from the tail? So we can change this to tail and change this to prev to read the list from the back. Exactly. You see, the order has changed. So this is our code. So this is for a linked list. Looks really great. I love the way generic work. And just for one last example, let me make something that looks more useful here. Let's create a struct for user and have a name here, string. Since we're in the same package, we can just have everything lowercase. So I'll create a users, l.new, list.new. I'm going to make this that is of type user that it can accept. So users.push Let's do pushback. Why not? User, this time name, AJ. We can just add more, MK, and then AB. Pushback, this is at the back, followed by this. So AB is at the back. So we can go ahead and print it out again. Node is users. So in short, let's print from the head. Node users. If when node is not, instead of this, we can just say node 2. When node 2 not equal to name, node 2 dot value, node 2 equal to node 2 dot this. Let's run it again. So we have AJ. Something is wrong here. AJ. Node 2 equal to users.head. For node 2 not equal to name, node 2 dot value, node 2 equal to node 2 dot next. Yeah, so when you are printing from the head, you got to continue going right, next. When you are printing from the tail, you have to continue going previous. So our code is correct. We can now run it again to see the two values, right? AJ, MK, AB. So if you want, you can change it to the tail, and then you have to change this to prev for it to work. Exactly, you have the AJ. So you see now, because we're doing pushback, this is at the back right now, followed by this, and exactly that way it's printed. So this is our code. Thank you. I'm going to make the second video for the queue.